All right, hey, I'm gonna get started here. So this is the second lecture for data science with Kaggle Decal. First, I want to start off with a rundown of course links. They're all here. The slides should be linked from the repo, and they will be linked from. That's next. Yeah. So yeah, all the links are here. Basically, you're probably all familiar. I added one more for office hours. Those are also available on the website. Pretty much most of this should be navigate. You can get to all of these links from the website. So, cool. Next thing is course announcements. So I imagine a lot of you have tried to actually enroll in the course and you had a problem with the permission number. We are currently trying to figure out the issue with the actual enrollment. So if you guys didn't notice, there's like one person enrolled in the class. There's only capacity for one person. We don't know who this one person is, who they actually enrolled or anything like that. So yeah, there's some weird bug. I've reached out to a few people regarding this situation, and hopefully we. Well, I reached out to somebody who's here, hopefully. But yeah, we'll figure that out before the drop deadline, which is next Friday. So don't worry. For those of you who haven't gotten Docker or Anaconda set up, please message us on Piazza or find us at our office hours. Everybody except for me has appointment-based office hours, so definitely make sure you check that and email the correct person regarding the office hours. I hold mine every Tuesday, 3:45 to 4:45 in Corey. Supernode, like the second floor kind of lounge area. So yeah, you can find me there on Tuesdays. But before then, you probably should reach out to somebody else. Here's a list of office hours again. Just gonna skip that. You guys can find it. Okay, so the first thing you want to do for this lecture is go to the path that you cloned the Kaggle directory and git pull it. If you guys have not git cloned the directory, then you'll want to do that now. I can just run through that really quickly. 1 second. So all you need to do is git clone, find the repo link. Actually, this is sufficient. So git clone. Oh, I need to zoom that in. 1 second. Git clone. Type in the URL, and it should download. It'll take I don't know, like 10 seconds or something on the school Wi-Fi. Then you should be good, and you can just cd sp17, and it's all there. Now, with this in mind, what you'll probably want to do is actually run these commands here. So make sure if you've already cloned it, you need to git pull. Then run the Docker command that we had you run last time. Make sure it's that command that I posted. And it should create a Docker container, drop you in. Oh, whoops. I already have one running. So if you get this problem, it means you already have it running. You can probably just run with it. Or otherwise, you'll probably want to do Docker PS. Whoa.
Do Docker list.
No, PS is the one. Yeah, no, I have some problems. So this is a weird issue with Jupyter notebooks. I probably have one running in the background. So yeah, if you have an issue like this, you can easily just change it and just put 88889 instead of 88888. But usually you should get away with 88888. Cool. And so it should drop you into this root user, and then what you'll want to do is run the second command or the last command. It'll give you a link, and then you want to go to that link, and you should be good. Should be good to go. Oh wait, this looks. Oh, here you go. It's right here. You can open up the slides from the. There should be a link from the repo if you go to day 2 in the repo here. So go here, day 2, and then there should be a link right here. There you go. All right. Oh, if you have an issue with the token, just copy it from the output, from the terminal output, and you should be good to go. Yeah, so let me make sure that everything else is here. Cool. So today's lecture is going to be an intro to Numpy. So for those of you who have used Numpy before, yeah, this will probably be kind of a review for you. We're not going to go too in depth into what Numpy could do, but it's a very powerful package, and it is definitely going to be a thing we'll rely on a lot this semester. So yeah. Data science, machine learning, well, this will be like kind of the standard. So the basic idea is Numpy is adapted from Matlab, And so there's a lot of the same syntax kind of copied over. But you get to use Python instead of a proprietary language like Matlab. It's great for supporting large multi-dimensional arrays. In the context of machine learning and data science, this will look like vectors and matrices. And if you get more into neural networks, that becomes like tensors, which are basically just multi-dimensional matrices. So yeah, and the great thing is that makes all operations super parallelized, meaning that you can run like huge computations rather quickly because you exploit this fact that matrices can be computed in parallel. And these matrix operations and vector operations are the backbone of machine learning and data science. And as a last note, all of this compiles down to C, so you're not even dealing with like Python code at that point. As a note, wait for the end of the lecture to do this, but we have a problem set. So just make sure that you do this problem set. It's fairly simple. If you've learned Numpy already, you'll be able to do it rather quickly.
We also have a harder one that's just the answers will already be there, but we recommend you still look at it.
Yeah, it'll definitely be very important that you know that for the class itself as well as in the future when you end up applying this in other scenarios as well. As a note, we'll have some time at the end of class. We'll have actually probably a lot of time at the end of class to go over this with some partners. Make some friends. Do it with your friends. It'll be a lot easier that way. Cool. So I'm going to get started with the notebook. Is anybody having troubles setting up their Docker environment or Anaconda environment? You are? Can the instructors here help out? Setting everybody up?
Wait, who? Hands up, hands up. Cool. Let's move for the back.
All right. Yeah, so if you have any problems, just come to the back. These three will help you out as best as possible. Cool. So in the meantime, I'm going to just go through a rundown of how to use a Jupyter notebook. So this shouldn't be too involved. This will just kind of give you like shortcuts here and there about how to do like very simple things with Jupyter notebooks, as well as like kind of make your life easier using them. And there are a lot of the things that I apply every day whenever I use a Jupyter notebook. So I'm going to pretty much ignore most of this text here. The basic idea is that I ripped all of this from a different course, so I wouldn't have to write it. But the basic idea is that you have all these packages here that you need to import at the very beginning. You have your Numpy library, which is you'll see a lot, and then you'll have this Matplotlib library as well. And finally, you'll have this magic function at the bottom, which basically makes it so that Matplotlib will be displayed inline and will be like you can actually interact with it. Otherwise, it would try to open it in another window. And if you have a Docker container, then you'd have some problems. Do you want to move up front, Tracy? Yeah. So all you need to do to run a cell is just press Shift Enter, and sometimes it'll give you this warning, especially if you're using the Docker container we have. But don't really worry about it as long as nothing breaks, as long as you don't get any proper output. But yeah. So I can talk about what Jupyter really is. It just basically allows you to display code and text at the same time. So the code is formatted with Markdown, which is basically just a nice way to generate like HTML renderings and stuff like that without having to use any crazy syntax. As you can see here, we can just make like a header by using 2 hashes. We can make links by wrapping everything with brackets, and then we have parentheses with the actual URL located. Additionally, we can write stuff in LaTeX, which, if you're not familiar, is a way to render math very nicely. I think there's more at the bottom here. Nope, just kidding. But yeah, you can write nice stuff like let me see. So if you wanted to write some LaTeX, you could be like a equals x. Let's see, vec x tb. And now you have some nice rendering of your math here. Cool. So Jupyter Notebook gives you all of these commands, and it's pretty great. You can read more about the details here. And so the most important thing I think that will come out of this particular notebook is this table right here. So it just gives you a list of shortcuts that are just totally invaluable for this, whenever you use Jupyter Notebooks. The most basic one you're probably The most basic one you're already familiar with is the run cell shortcut. Basically, Shift plus Enter will let you run a cell, and then you can the other commands rather that are pretty important as well are the ones that allow you to make like new cell blocks, which you basically just escape. and then press A. So I can do that here, and then just adds a cell block above. Oh, whoops. And then you can delete a cell by double-clicking D. Oops. Sorry, one sec. Oh, wait. So yeah, you can delete a cell by double-clicking D. You can add some below a cell by pressing B, and you can convert a cell to Markdown, so you can start typing cool Markdown stuff. And you can also convert a cell back to code by pressing Y. So all of this, you must be escaped from a cell. You can't be, so you're in enter mode if the cell is surrounded by green. You're in the mode where you can actually use all of these commands if it's surrounded by blue. Okay. Does anybody have any questions regarding all this stuff? If you have any questions regarding a person in the white shirt, Leslie, sorry, can you move to the back if you need any questions with that? Yeah, okay. All right, so here's the code cells. Pretty simple. You can just you can pretty much just print out anything you want. So as a note, you can pretty much output anything as long as it's in the bottom line of a cell. So this print right here isn't really necessary. Instead, we could just remove that print, and it'll just output it straight to the line below as output. The same thing happens here. So spam plus x doesn't output because it's not the last line, but spam times 5, basically multiplying this list 5 times, will appear at the bottom. And whenever you assign a variable, nothing is output. So if you see right here, nothing is output after line 4, but after after in 5, there's an 11 displayed. And now, like a pretty big win that comes with Matplotlib is the display of graphics inline. So you can see here is we use a Matplotlib kind of initialization. You don't really have to worry about the content here, but the key thing is that we run this plt.plot, and we input x and y. And so this basically is the x coordinates and y coordinates. They're both vectors. And then it aligns them and displays this nice plot here, which is like a sine, kind of a sine wave. Cool. Additionally, you can do some subplot stuff, just mix plots together. Check out all of these if you want more details on how you could do it. Oh, finally, you can add some cool graphics as well. But everything else, you should really just check out on your own. I'm going to move on to the next part. All right. So I'm going to open up the next notebook, which is Intro to Numpy. So, yeah. If everybody could get that open. Let's see. So the first thing we want to run is matplotlib inline. This would just make sure that the matplot, all the matplot plots we use are going to just appear within the notebook properly. I mentioned that before. But yeah, that just makes it a lot easier to deal with. And now you can skip all these stuff. There's also a bunch of cool resources on, I think, Numpy specifically. Not exactly sure where. But yeah, don't really worry about this stuff right now. So the first thing you want to do is import your Numpy. Then it's gonna then this last line right here just shows that the Numpy module is imported. So you can be sure. Finally, next we want to import Matplotlib so that we can display everything in line. And here's an example of Matplotlib again. This time just a sine wave. I just want to note that the syntax here again is pretty similar. So we have our linspace right here. As an explanation, it basically takes all the points from it takes 200 samples between 0 and 2 times mp.pi. And so it basically just makes a vector of length 200, evenly spaced from 0 to 2 pi. And then it passes all those values into the sine function, evaluates the y value at those places for every single point in that vector, and outputs a new vector y with the same length. And then you can as long as they're the same length, you can run plt.plot with the values as the input. And then when you do plt.show, it displays it on the screen. Cool. So here's some loop stuff. Most of you, I think, have taken 61A before, so you should be fairly familiar with that. Next, you have your lists and stuff, and here's how to index lists. Most of you have already seen this before. You can reverse a list by using this syntax, and then pretty much all this nice stuff you've already seen before. And now here comes the key critical part that comes with Numpy. So whereas like regular lists have or regular Python, vanilla Python has lists and stuff, arrays, or Numpy has arrays. Numpy arrays basically act as like fixed sized vectors, or rather fixed size like lists themselves, similar to how Java does it and everything like that. The nice thing is they give you all this extra like matrix operation, vector operation power, and it's really easy to initialize them. So you can create a vector from a list by simply just writing np.asArray, or alternatively you can literally just write np.array and wrapper list. Additionally, you can make a matrix of all zeros by just literally using the zeros keyword and inputting a shape right here. So this will create a matrix that's 3 by 3 and it has all zeros. And so to do any kind of vector operation or matrix multiplication, you basically just need to use this @ operator. Now this is kind of introduced with the newer version of Numpy, and I actually think it may fail here. Yeah. So the package that we included with the Docker actually does not have the syntax yet, and so you'll probably have to default to this version right here. We'll update the package so that it actually can use that, but for now you're gonna have to roll with this. So just replace those ats with dot basically, and so that does the same operation. When you do end up using something Numpy for like Python 3.5 and stuff like that, you can basically just get away with the @ symbol. It makes it a little bit cleaner, a little bit easier to deal with, and a little bit more like how you'd conceptualize a matrix operation when you're writing it down normally. And as you can see here, we can print it all out. So we print out our vector, it gives us this output right here, and then we take out the matrix, the vector matrix product, and if you multiply a vector with a 0 matrix, then it's going to output zeros. And then the inner product of the vector with itself, which should just be 14. As a note, whenever you output a like Numpy or Numpy matrix or a vector, just in the very last line, it won't print it out like this. It'll print it out with this wrapping of array. So just keep that in mind when you're doing stuff. What's up?
So arrays are only vectors, or can you like nest I guess more like brackets?
So you have to be very strict about like maintaining dimensionality in that case. So you can nest, but the only way you can do that is if you do something as long as you have the full dimensions like filled in. So you can't do something like let's see, 1, 2, 3. Like I think this should throw an error. If it doesn't, it'll do some like weird operations. 1 second.
So basically, all of the rows have the same number of columns.
Yeah. So as you can see, this does not work, but this,
Let's redo that.
as long as they're like 2-dimensional arrays, and yeah, as you said, the rows have the same number of columns, then it should work.
So this would be a 2 by 2 matrix.
A 3 by 2, but that's because of rows then columns first.
Wait, so they display all vectors horizontally, not vertically?
Yeah, you define the row vectors in this case. Yeah. Any other questions? Yeah. No, 1, 2, 3 is a row vector. So Numpy constructs row vectors instead of column vectors, and that's just how it rolls. That's really just convention. That's the convention you'll probably see in 189 when you end up taking it, and I think that's just the standard that they adopted. I'm pretty sure that's the standard that Matlab set, anyways. So yeah. No, you first. Yeah. Oh, multiply. Wait, what do you mean? Multiply like every single value inside of it? You can do something pretty simple, like just the array, the like Numpy matrix and vector or whatever, just times 3. So if we want all these to be multiplied by 3, that's it. That's all we need. It's very nice. So it makes it really easy. Hey. 2 vectors? Oh yeah, that's also pretty easy. It's the same operation, but you just need 2 vectors instead. So I'll do something like, and then times. There you go. Yeah, so it'll just element wise. Now if you want to do a dot product, which is kind of a similar operation, but it can be like counterintuitive, just use the dot syntax.
Okay, so if you do np dot dot, that goes to the matrix vector product. If you do like an array dot dot, that does the.
Wait, are you talking like np dot dot like that?
Yeah, so
No, it's actually the same thing. So this is, I can even show you. It'll be the same operation.
Okay.
Now, let's say you mentioned that you wanted to do like a matrix and stuff, right? So as you can see here, this is a matrix, and it takes the dot product of a vector, so it's like matrix multiplication. And as you can see, it outputs a vector as well. It's the same syntax as before, and you can interchange it. It's just the dot dot after, so it's like matrix dot dot is basically a shortcut to do that operation. Yeah.
So what operation does the asterisk do?
The asterisk, this right here.
Yeah.
It's just multiplication. It's element-wise multiplication.
Oh, okay.
So if you have a scalar, then it's going to multiply every single element of that vector by a scalar. If it's another vector, it's going to multiply each respective element of those two vectors with each other. So it'll multiply the first element of both vectors together, the second element, and so on. Any other questions? All right. And like a nice thing that I really like to use, and I think it'll become very apparent why it's important as you do more like machine learning data science stuff, is shape stuff. So basically, it's just a shortcut to get the shape of the matrix, and this is a good way to check your work a lot of the time when you're doing like a bunch of matrix operations. So all you need to do is just get the vector. You can just call it by the like array name dot shape. So we have our vector and matrix from up here, and we can just get their shapes by just running these lines right here. Cool. Yeah, that's pretty much everything for the lecture. So, does anybody else have any more questions about the Numpy stuff or matrix stuff? Anything in general? Cool. So open up pset 1. We will be submitting to Gradescope. So we set up a Gradescope. There's a guide to get enrolled at the very bottom. So make sure you just follow that when you go on to submit something. Yeah. The course of enrollment, no, it has not been fixed. Yeah, so we're definitely emailing as many people as we can right now, so that it gets fixed. So yeah. I set one arbitrarily. I think it's like the 12th or something. It should not take you that long. I bet you could finish it now with like a little bit of Googling and stuff like that. Let's see. It's due February 12th. Yeah, it should be fairly quick to do. Right. Let me just make sure that I covered everything I wanted to. Okay, cool. By the way, the quiz link is at the end of the slides, so feel free to go open up the slides and click the quiz link. Oh, Hamza. Did you get the quiz link set up?
Yeah, it's a hyperlink. Just put on the quiz link right there and it'll take you there.
Oh, yeah. I could do that myself. Shannon, don't break anything.
What?
You're the only person who has edit access.
Nice.
Cool. Whoa. If you have any questions about the quiz, like, feel free to ask me. Also, you can Google it probably. Oh, hey, if you want to test anything for the quiz itself, just like do it in your notebook. Do it in your problem set notebook. So because it'll just give you the ability to run stuff really easily. Right. Oh man.